You know, every single day we're installing updates, downloading apps, running new programs, and we're placing a ton of trust in all that software that pretty much runs our lives. But have you ever stopped to wonder how we really know any of it is safe? Well, let's pull back the curtain on the invisible security system that keeps your digital life from basically falling apart.
Come on, we've all been there, right? You download something, you go to open it, and your computer pops up this warning, asking if you're really sure you trust the publisher. And you get that little moment of hesitation, right? That warning you see, that's actually your first clue that there's a much bigger security system working in the background to protect you.
So yeah, every time you click Run, you're kind of taking a leap of faith. You're trusting that the software is actually from the company it says it is, and you're trusting that some hacker hasn't messed with it on its way to your machine. But the good news is, there's a whole system designed to turn that leap of faith into a much more calculated and much safer step.
And that system is called code signing. That's what we're talking about today. At its heart, it's basically a way of putting a digital tamper-proof seal on a piece of software. And this seal, it tells your computer two really important things before it even thinks about running the code.
So what are these two big promises? First is authenticity. The signature proves that the software really came from the developer who claims to have made it, no imposters. Second is integrity. This guarantees that the file you downloaded is the exact same one the developer created, with zero malicious changes made along the way. The best way to think about it? It's like a notarized document inside a sealed envelope. You know who sent it, and you know nobody opened it.
Okay, so a digital notary, how does that actually work? It's not just a two-way street between the developer and your computer. Nope, there's a super important middleman that helps create what we call a chain of trust. So let's break down who's involved. First up, you've got the developer, obviously the person or company who wrote the code. Then you have the certificate authority, or just CA. Think of them like a passport office for the internet. They're a highly trusted company whose job it is to verify that developers are who they say they are. And finally, there's your operating system. Windows, macOS, you name it. It's the final gatekeeper that checks all the credentials.
And it all works in about 4 steps. So a developer goes to a CA and proves their identity to get a special digital certificate. Then they use a secret private key, which is like their own unique, unforgeable seal, to sign their software. Now, when you download that software, your computer uses the matching public key, which everyone has access to check the signature. And if that public key can successfully verify the signature made by the private key, then your OS says, okay, we're good to go, and trust the software.
And this is really the key to the whole thing. Your computer already has a built-in list of CAs that it trusts by default. So you're not actually being asked to trust some random developer you've never heard of. You're trusting the trusted authority that already checked them out and vouched for them. It's all about that chain of trust.
Okay, I know this might sound a little abstract, but believe me, you are interacting with this system all the time, probably without even realizing it. It's like the invisible security guard of your digital world. Let me show you a few places where you see it every day. Think about it. Those critical security updates you get for your computer? Code signing is the very thing that guarantees that update is genuinely from Microsoft or Apple and not some fake patch from a hacker who's trying to take over your entire system. Oh, and if you have an iPhone, well, you're basically living inside a fortress built by code signing. Apple demands that every single app is signed with a valid Apple Developer ID. It is a strict, no signature, no entry policy to get into the App Store.
You know, when you plug in a new piece of hardware, like a mouse or a graphics card, the software that makes it run, the driver, operates at a really deep level of your system. So Microsoft, for example, has a really tough signing process to make sure those drivers are legit and won't crash your computer or create security holes.
And hey, it's not always just about keeping you safe. Sometimes it's about control. Console makers like Sony and Microsoft use code signing to lock down their hardware. Your PlayStation or Xbox will only run games that have been signed with their secret key. It's one of their biggest weapons in the fight against piracy.
But, you know, no security system is perfect. And this is a big but. That chain of trust is only as strong as its weakest link. The system is incredibly powerful, but it's not foolproof. And it's super important to understand where it can all go wrong.
It all comes down to one thing, one single point of failure: the developer's private key. If a cybercriminal manages to steal that key, they can sign their own malware and make it look like it's coming from a legitimate, trusted company. And just like that, the entire system of trust for that developer breaks down.
And it's also really important to understand what code signing does not do. A valid signature doesn't mean the code is perfect or bug-free. And it doesn't even guarantee that the original developer isn't a bad guy themselves.
All a valid signature proves is who the author is and that the code hasn't been messed with since they signed it. That's it.
So, with stolen keys being such a massive threat, the whole industry knew they had to do something. They've made a really big move to try and shore up that weak link, and it fundamentally changes how these all-important keys are protected.
And that brings us to this date, June 1st, 2023. You're going to want to remember this one because it was a total game changer for code signing. A new, much stricter rule for the entire industry went into effect.
Basically, the folks who make the rules laid down the law. Private keys can't just be a file sitting on a developer's computer anymore. Too easy to steal. Now they have to be generated and stored on a physical, secure piece of hardware, like a special USB token or a dedicated high-security box called an HSM.
And why is that such a big deal? Well, think about it. You can't just copy and paste a key off a physical device like you can a file. A hacker would have to physically steal the hardware itself, which is, well, it's a whole lot harder. So this one change, this one new rule, makes the entire system way, way stronger.
So when you get right down to it, code signing gives us this incredibly powerful guarantee about where our software comes from and that it's arrived intact. It's an absolutely essential layer of security. But it also leaves us with one last big question. Knowing who made something is one thing, but deciding whether you can actually trust them, well, that's another story entirely.